In this video, we're going to talk about some different patterns of exponential growth, the different patterns that we get when we have powers of different kinds of numbers. So the first thing I'll emphasize in this video is not about the exact calculations. I would say worry less about the exact values of the number. What's important to get from this video are the patterns, what's getting bigger, what's getting smaller, and when. And it's very important to be aware of these properties in a variety of questions. The test absolutely loves these patterns and asks about them in several different ways. For different bases, we will look at what happens to the powers when the exponents increase through the integers. So case 1, we're going to have a positive base greater than 1. We've already seen this in the last video. I'll use powers of 7 as an example. 7 to the 1 is 7. 7 squared is 49. I mentioned in the last video that 7 cubed is 343. That's a good number to know. And then as we get to higher powers of 7, these are not numbers that you need to know. I'm showing you these higher powers only to emphasize that exponential growth starts to get very big very quickly. So this is one good idea to keep in mind, that if you have a base greater than 1, and especially if it's greater than 5 or greater than 10, then what's going to happen as you start raising powers of it, it's going to get inconceivably big very quickly. So the big idea here is a positive base greater than 1, the powers continually get larger at a faster and faster rate. That's very important. So that's pattern number 1. That's the pattern when we have a positive base greater than 1. Suppose we have a positive base less than 1. Okay, well this is interesting. Let's say 1/2, for example. So 1/2 to the 1 is 1/2. 1/2 squared is a quarter, then an eighth, then a 16th. Notice that things are getting smaller and smaller and smaller. We get down to 1 over 128 and finally down to 1 over 256. So we've gotten very, very small at this point. So much as in the first case we got big very quickly, now we're getting small very quickly. It's possible for higher exponents to produce smaller patterns. So in other words, as we raise the exponent higher and higher, it's possible for the overall power to get smaller and smaller and smaller. And so this is an important thing to keep in mind. Numbers, when we have a base between 0 and 1, a positive base less than 1, then we're going to be following a very different pattern for exponential growth than if the base were more than 1. Now, even more interesting, let's talk about a negative base less than -1. So this is a number that is negative and it has an absolute value more than 1. So for example, let's just take 3. 3 to the 1 is 3. 3 to -3 squared is positive 9. -3 cubed is -27. -3 to the 4th is positive 81. -3 to the 5th, we talked about this a little in the last video, 3 to the 5th is 243, so -3 to the 5th is -243. And -3 to the 6th is positive 729. So again, notice we have this alternating pattern. We saw this alternating pattern in the previous video. The absolute values of these powers are getting bigger each time, but the positive and negative signs are alternating. So this combines the idea of case 1 with continuously getting bigger. What's continuously getting bigger are the absolute values of the numbers, but the actual number itself is flip-flopping between positive and negative. So we get a big positive, then a bigger negative, then a bigger positive, then a bigger negative. It's going back and forth like that. So you can imagine these wild jumps on the number line from a very large positive number to a very large negative number. That's what's happening when we raise a negative base less than 1 to these powers. Finally, the last case, a negative fraction. That is to say, a negative base between 0 and -1 and 0. So this would be a number that is negative and has an absolute value less than 1. It is between -1 and 0. So let's take -1/2. -1/2 to the 1 is, of course, -1/2. Negative 1 squared is positive 1/4. Negative 1 cubed is negative 1/8. Negative 1 to the 4th is positive 16. Negative 1 half to the 5th is negative 32. Negative 1 to the 6th is positive 64. Negative 1 half to the 7th is negative 128. And then positive 1 over 256. So notice, similar to what was happening in case 2, the absolute values are getting smaller and smaller, but we're flip-flopping again between positive and negative. So we're getting closer to 0, but we're getting closer to 0 by jumping back and forth above 0 and below 0. We're approaching 0 by this kind of skipping pattern, going above it and below it and getting closer each time. Notice that as the exponent increases, whether the power gets bigger or smaller depends on the base. So if we ask the question, is x to the 7th greater than x to the 6th? Well, there's no clear answer. It would be true for positive numbers greater than 1 and false for negatives. Also, if x equals 0, x to the 7th would equal x to the 6th, which would be 0. And that's also a no answer. X to the 7th would not be greater than x to the 6th if it's equal to x to the 6th. Now consider this question. If x is less than 1 and x is unequal to 0, is x to the 7th greater than x to the 6th? Well, we have to consider what happens in different cases. First of all, it's very easy to think about what happens with the negatives. If x is negative, then x to the 7th is negative and x to the 6th is positive. And any positive is greater than any negative. So therefore, we're going to get a no answer to the question. We're going to get a clear answer of no. X to the 6th is definitely going to be bigger if x is negative. What if x is a positive number between 0 and 1? So these are the only positive numbers allowed, the positive numbers between 0 and 1. Well, if we square, say, 2/3, square that, we get 4/9. If we cube it, we get 8/27. Now notice that 4/9, 2/3 is above 1/2. 4/9 is slightly below 1/2. It's above 1/4. 8/27, well, 8/27 is definitely less than 1/3. 4/9 is greater than 1/3. 8/27 is less than 1/3. Then we get to the 16/81. That's actually less than 1/4. And what's happening is that these numbers are getting smaller and smaller. And this is what we've seen in these powers. This is our case 2 above, where we have positive numbers less than 1. As we raise higher and higher powers, we get smaller and smaller numbers. So we can definitely say that the powers are getting smaller. So if we extend this pattern, of course, x to the 6th is going to be bigger than x to the 7th. This is also going to produce a no answer. And it turns out that the answer to the question is a consistent no for every x allowed. So we can give a definitive answer of no to this question. In this video, we discussed the patterns of exponential growth, how increasing the exponent changes the size of the powers for different kinds of bases.